track the number of electrons that are being transferred in or out. Okay, we never get rid of electrons, and electrons don't just freely hang out there. They have to be accounted for. Okay, and this is where it says oxidation numbers do not represent the actual charges on ions, but they're designed to bookkeep the electrons. Okay. So, general rules for assigning oxidation numbers. A pure element in atom form has an oxidation number of 0. So, if we look, we're going to run 2 pages together at the same time. So, on this sheet here, example number 1, it says, because here it says, see example number 1. Let's look at, it's probably on the back side of your note page. Okay, so I will put this back up, but I'm just going to explain it. Like, I'll give you time to write this down. So Br2 liquid, this is bromine in its atom form. Okay, so this is, so oxidation number gets written as ON. Okay, that's short for oxidation number. And so for bromine, it is 0. Okay, so don't worry about flipping back and forth, but this is where it says see the example. It's going to be on this sheet. I'm going to go back and forth. Okay, next one says group 1 metals always have an oxidation number of +1. That's their most common charge when in ion form. And group 2 metals always have an oxidation number of number 2 when in ion form. So we're going to go on this page, number 5. So, yeah, sorry. This says see example 5. Okay, so let's look at a compound called barium nitrate. If I was to break these 2 compounds into their original, or into their individual components, I would have barium and I would have nitrogen and I would have oxygen, right? Barium is in what group? Open up your periodic table if you don't remember off the top of your head. Think it's group 2? Can anybody confirm? Group 2. So the rule says group 2 metals always have an oxidation number of +2 when in ion form. So this is going to have an oxidation number of 2. Okay. When we look at nitrogen and oxygen, we're going to come back to that one. But this is group 2. This has a 2 for an oxidation number. Okay, because barium is in group 2. In group 3, in general, most metals will have an oxidation number equal to their charge when in ion form. If I was to break up zinc chloride, I would end up with a zinc ion and I would end up with 2 Cls, right? That's how we break those up into their ions. We'd have zinc 2 plus and we would have 2 Cl minuses. That's how we break up zinc chloride into 2 ions. So zinc has an oxidation number of, what is its charge? 2. Zinc has an oxidation number of 2. Okay. When we go to number 4, it says the oxidation number of oxygen ions is usually -2. but there's two exceptions. If it's mixed with, if it's in as hydrogen peroxide, or if it's mixed with fluoride. So let's look at those. It says C4, 5, and 6. So 4 is, if I was to break down, look in your polyatomic box. What is this compound called? Permanganate. Okay? If I was to break these apart, I would have Mn and I would have 4 oxygens. Right? So when we look, we don't quite know the charge of manganese just yet, because when we look at manganese in the periodic table, what is its charge? It's which? 2 or 4. Well, if I put 2 in here, and then that's 2 positive, and that's 4 times 2 negative, that would be 8 negative. So then 2 plus and 8 negative are not just 1 negative extra. 4 plus. Well, we're going to talk about oxygen. Okay? So this is what we're going to do. We don't know this. We're going to call it X. And then we're going to look at oxygen being -2, because that's the most common state. And this has to equal to what? We have a residual charge. Has to be equal to -1, because I have an extra negative charge here. I have an extra electron hanging around. So then what does my X equal to? Well, -1 plus 8. X is equal to 7. So manganese's oxidation number is equal to 7. And oxygen's oxidation number is equal to -2. When we go to barium nitrate, we didn't finish this one off. So we have nitrogen and we have oxygen. Is oxygen bonded? Is it there as hydrogen peroxide? Is it bonded to fluoride? So then oxygen's number, there's 2 of these guys, and there's 2 of these guys. Oh, you're right, there's 6 of those guys. So oxygen is going to be a -2. If it's, the rule says the oxidation number of oxygen ions is usually -2 unless it's hydrogen peroxide and fluoride, this oxygen fluoride compound. So when it's not that, it's going to be -2. We're going to put an X here for nitrogen. This is going to be equal to 0 because it's balanced. This compound is balanced. So I have 2 plus 2x plus -4. I did it 6, sorry, -12 is equal to 0. My 2x is going to be equal to 10, which means that my x is equal to 5. So nitrogen has an oxidation number of 5. 5 positive or 5 negative? What was our answer? Positive 5. Okay, so barium is a 2 and oxygen is a -2. Okay, let's look at this one. Actually, let's do some rules. We'll look at 6 at the very end. Okay, hydrogen ions usually have an oxidation number of +1 unless it's listed as a hydride. So how do we know something is a hydride? Do you remember? Okay, let me give you 2 examples. In this compound here, is hydrogen positive or negative? How do you know? I actually wrote this wrong. There we go. How do we know that hydrogen is positive? Look at your polyatomic box and look for carbonate. It's got a negative charge, so hydrogen must be the positive charge. Hydrogen is acting as the metal, whereas carbonate is acting as the nonmetal. In this one here, sodium is it's the metal, and so hydrogen is the nonmetal. This is sodium hydride, whereas this is bicarbonate. Okay? So if it's a hydride, if it's common ones are calcium hydride, sodium hydride, I think maybe like magnesium hydride. They're very reactive. Okay? It's typically in the second position, in the nonmetal position. So let's look at number 3. So this is a gas. What's that guy called? Do you remember? 2 units ago. Methane. Okay? Carbon is first. So carbon, well, carbon is first, so we're going to say it's a metal. Where do we find carbon on the periodic table? On the right side of the stairs. Carbon can have what charge? +4 or -4. So we're going to say that this hydrogen, so carbon and 4 hydrogens, this is going to be X, because we don't know, is it positive or negative, plus +1. And I'm saying +1 because this is not carbon hydride. This is methane. So unless you actually have the word hydride in the sentence of the name, it's going to be a +1. Whoops. And then it has a balanced charge. So then X must then be equal to -4. So carbon's oxidation number is -4, and hydrogen's oxidation number is +1. We'll quickly go through the other rules. Fluorine ions always have an oxidation number of -1. Chlorine ions, what group is fluorine in? Group 17. All of those atoms have a what charge when they're in their ion form? -1. Well, let's look. Rule number 7. Chlorine ions usually has an oxidation number of -1 unless they're bound with oxygen and fluorine. So chlorine is always -1 unless it's bound with oxygen and fluorine. Because fluorine is always -1, which means that chloride would then be +1, or whatever charge if it's in a compound. And then here's the exceptions to the rules. For all other ions that do not fall under the rules listed above, oxidation numbers need to be calculated based on 2 of the following principles. The sum of all the oxidation numbers of all the elements in a neutral compound is 0. So like when we look at zinc chloride or barium nitrate or ammonium sulfate, those all have a net compound charge of 0. Then you have to look at the sum of all of the oxidation numbers. And then sum of all oxidation numbers of all the elements in a polyatomic ion equals the charge. So for example, when we looked at this one here, this is a polyatomic compound. And so when we were solving for it, we set it equal to -1 because that's the remaining charge. That's the electron we have to account for. Let's look at ammonium sulfate. We have 2 unknown oxidation numbers. Hydrogen is going to be, this is ammonium. So is this hydrogen positive or negative? So this is +1. We don't know nitrogen. Sulfur we don't know. And oxygen is -2 because is it hydrogen peroxide? And is it bound to fluoride? No, so it's -2. So sulfur is going to be a Y. So what we're going to do is we're going to solve these each individually. We're going to look at 2 individual polyatomic pieces. I'm going to, okay, I'm going to write this out in bigger space. NH4 to SO4, ammonium sulfate. So NH4, look in your polyatomic box. What does it have for a net charge? +1. And sulfate? 2 negative. So I'm going to have my X plus 2x plus 8 times +1 is going to be equal to +1. So 2x because there's 2 nitrogens, and 8 because there's 2 groups of 4 hydrogens. Okay? Those subscripts become very, very important. Equal to +1. Yep. So I'm going to have 2x plus 8 is equal to 1. 2x, did I do this right? No, I didn't do this right. I should still work out. I did this wrong. Sorry. Good thing I caught myself. We don't need to look at the 2 part. We just need to look at the compound part. Do you know how I knew I had done something wrong? I would have had a fraction, right? I would have had 7/2 equals x. Oxidation numbers are whole numbers, okay? So x plus 4 times +1 is equal to +1. X plus 4 is equal to 1. X is equal to -3. So nitrogen has an oxidation number of -3. When I look at sulfate Sulfur we said we didn't know. Plus there's 4 times, what did we say oxygen would be in this particular case? And it's going to be equal to -2. So y minus 8 is equal to -2. Y then is equal to, say it again, 6. So sulfur's oxidation number is +6. So I can go back up to this original thing. And I can say that nitrogen is -3, hydrogen is +1, sulfur is +6, and oxygen is -2. Oops. Those are the oxidation numbers. Now, does that make sense for nitrogen to be -3? What group is it in? Group 15. Okay. Does it make sense for sulfur to be +6? On that same premise? Not really, because sulfur is in group 16. So the nonmetals definitely don't follow those patterns. And they definitely don't match up their charges with their oxidation numbers. So an oxidation number is strictly keeping your electrons of your compound in balance. Okay? So I'm just going to fill this in. To complete your pages, you can. Oh, we didn't finish off chloride. Up here, zinc has a 2+ charge, or 2+ oxidation number. Chloride would have what oxidation number? -1. Okay. Molecular compounds. What's the definition of a molecular compound?
That's the gases, right?
Typically 2 nonmetals. Hydrocarbons are molecular compounds because they got carbon and hydrogen. But typically there are 2 nonmetals. A molecular compound that does not have hydrogen, oxygen, fluorine, or chlorine, that do not have oxygen, fluorine, or chlorine, the more electronegative element gets assigned an oxidation number of its oxidation charge. So, what does that look like? It looks like this. So this is silicon bromide, SiBr4. Where do we find silicone? Right side of the stairs. Where do we find bromine? Right side of the stairs. So when we look at our data booklet, we see silicone here and bromine here. So silicone has a electronegativity charge of 1.9 and bromine has an electronegativity charge of 3. Right? Your key right here says what they are. So because bromine is more electronegative, its oxidation number is its common charge. Okay, it has a -1 charge, so that is going to be its oxidation number because it's more electronegative. So then we have, so yeah, that's fine. We have, we don't know the charge of silicone then, or the, not charge, the oxidation number, but we know that bromine, we just said, is -1 because it's the more electronegative. This is going to be equal to 0. So X is going to be equal to positive or negative? Oops. So silicone's oxidation number is going to be +4, and bromine's oxidation number is going to be -1. Okay, let's look at these questions. Let's go through them together. Okay, let's look at the rest of this. Let's look at a balanced equation between zinc and copper sulfate. So if I had zinc metal and I add it to copper sulfate, what kind of reaction is this? Single replacement. So I'm going to get zinc sulfate and copper solid. Now we're going to go all the way back to basics. Here's zinc. When it's in its atom form, it has an oxidation number of what? 0. When it's in its ion state, it's going to have a oxidation number of, can we tell? Okay, let's look at this one. Well, I'm going to change that all up on you. Copper as a metal has what oxidation number? 0. And we got to solve it. So what happens is we have to solve these pieces. So when we look at sulfate, we have S plus 4 times what's oxygen? -2. We equal to -2. So sulfur must then have an oxidation number of +6. Zinc, when I look at this, sulfate has a 2- charge. So zinc must be X is equal to +2, right? Because it has to come to a 0 balanced charge. So zinc, and I rewrite it, this is 2 plus, sulfur is 6 plus, and oxygen is 2 minus. Okay? Copper sulfate, let's do the same thing. Well, we already know that sulfur is +6 because we did the math over here. Oxygen is -2. Copper must be, sulfur is -2. Sulfate is -2, so copper must be +2. So now, when I have those pieces in here, this is +2, this is +6, this is -2, +2, +6, -2. Okay, we can see here that zinc goes from 0 to a +2. What does that mean? Did it lose an electron or did it gain electrons? It loses electrons. It goes from 0 to +2. What happens here when we look at copper? It goes from 2 to 0. It did. It gained an electron, so it was reduced because it went from 2 plus to 0. Okay? So this was an increase. This was an increase in oxidation numbers. This one here was a decrease in oxidation numbers. So maybe, Declan, that's one way that will help you out with trying to remember reduction. It's a decrease in oxidation numbers. That's being reduced. Okay? So we can say then that the zinc, a loss of an electron is oxidation. So zinc is oxidized, which means then that zinc is the reducing agent. Okay? Copper, when you go over here, we go Gur, is gain of electrons, so it is reduced. Therefore, copper sulfate is the oxidizing agent. Okay? When an element has an increase in oxidation numbers, that molecule is undergoing oxidation. When the element has a decrease, the element is undergoing reduction. That makes logical sense, I think. Okay? If we were to look at a number chart, and we put 0 here, yeah. Okay? When I have a number chart like this, if I'm going this way in oxidation numbers, if I'm going from 0 down, or +5 to -2, or even +5 to +3, if I'm moving in this direction, this is a reduction. And if I'm moving in this direction, it's an oxidation. Okay? When a reaction has no elements that have a change in oxidation numbers, then there's no electron transfer has occurred. It is not a redox reaction. There has not been a reduction or an oxidation, therefore it is not a redox reaction. All double replacement reactions are not redox reactions, all of them. So for example, if I was to take silver nitrate and mix it with sodium chloride solution, I would get silver chloride and sodium nitrate. This goes 1 plus, 1 plus, 2 negative, 2 negative, sodium is 1 plus, this is 1 plus, chloride is 1 negative, 1 negative. Nothing is changing. All single replacement reactions are redox reactions. Let's look at iron. And let's react it with copper nitrate. What's happening when we go from here to here? This oxidation number is 0, and this oxidation number is, most metals follow their charge. Be plus 2. And here copper as a metal is, what does it have for an oxidation number? Okay. And copper here would have a plus 2. Is that what you said, Declan? Okay. So 1 is being reduced. Copper is going from a 2 plus to a 0. It's going down the number line. It's being reduced. Iron is going up the number line. It's going from 0 to positive 2, so it's being oxidized. Okay? It is possible for some atoms of one element to undergo oxidation and other atoms of the same element undergo a reduction in the same reaction. Typically, we have one or the other. This is what we call a disproportionation reaction. Okay, so let's quickly go through this. What is the oxidation number of copper here? This is plus 2, or minus 2, sorry, for oxygen. What would this copper be? Plus 1. What about this one here? Hydrogen is? Oxygen is? Sulfur is? This copper is? This oxygen is? This sulfur is? And this copper is? And hydrogen is? And oxygen is? Negative 2. And then we start looking. Here's copper. And then we look again. Oh, but there's copper over here. Let me just finish this off. There's this copper. Hydrogens didn't change, sulfurs didn't change, oxygens didn't change. So we're just looking at the copper. But what we're seeing is it's copper oxide, copper 1 oxide, is affecting both copper and copper sulfate. So copper 2 oxide is both being reduced and oxidized. Okay? Okay, so when we're looking at a disproportionate oxidation reaction, redox reaction, it's when the reactant is both the reducing agent and the oxidizing agent. Okay? Typically, we see this with chloride, but this one in our example was copper. So copper went from a 1 plus to a 0 and went from a 1 plus to a 2 plus. So in this one here, it was reduced. And in this one here, it was oxidized. It's on the printer. Watch out for the bucket. Okay, determine whether each of the following reactions is a redox reaction. If so, identify the oxidizing and the reducing agent. So this is what I do still, 49 years old, I still do this. I do that. It's the first thing I do. I write that down. Okay? The combustion of propane in an open system. So first thing we have to do is we have to write out the balanced reaction. What's a combustion reaction? And? Yep. It said it's in an open system, so what state is my water in? Liquid or a gas? Gas. Okay. What's the next thing we have to do? Balance it. Always start with carbons first, and then hydrogens, and then 6 and 4 is 10. Do your oxygens. Okay, that's our balanced reaction. Now we need to look at each compound. What is the oxidation number of hydrogen in propane? +1. Why are you saying +1 and not -1? Because it's not a hydride. Okay, so if this is a +1, what do I say carbon is? So it's 3x plus 8 times 1 is equal to 0. So x is going to be equal to -8/3. And remember the other day I said it's going to be a whole number? This is the one time where we see fractions because we typically will see a fraction with the oxygen. Okay, so -8/3. Oxygen has what oxidation number? Ooh, this one is 0. Why are you saying 0, Haley? Because it's an element or an atom. Okay, how about this oxygen over here then? -2, which means that this carbon is +4. How'd you figure that out, Eric? -2 times 2. Okay? No, we don't look at the 3 out front. There's only 2 here. Because I needed to figure out carbon. So I have x plus 2 times -2 is equal to 0. X would be equal to +4. 2 times -2 is -2. When I bring it over to the other side, it becomes +4. No, not right now. Not in this case. Okay, so, and then over here, oxygen is, and hydrogen, +1. Just gonna pop. Josie will be good. Okay, let's look at what's changing. So we go from 8/3 to a +4 here. And here we go from a 0. I'll pick a different color. This doesn't show up very good. Maybe I got red. Red shows up. We go from here to here as well as to here. So when I go from -8/3 towards +4, is it being oxidized or is it being reduced? Oxidized. Oops. Okay, it's being oxidized because it's gaining an oxidation number. Now, this one here is going from 0 to -2. Is it being oxidized or reduced? It's reduced. It's going to gain an electron. Okay? And Riley, there's a little starred note here just for coefficients. Balancing coefficients doesn't affect affect oxidation numbers. Okay? So now that we've identified that methane is being, or propane is being oxidized and oxygen is being reduced, what do we say about oxidizing agents and reducing agents? Okay. And not carbon, the whole word, propane, reducing agent. Propane is the reducing agent, and oxygen is the oxidizing agent. And that's why I automatically do this. All I need to figure out is which one is losing electrons. All I need to figure out is which one is gaining electrons. And then the mnemonic, the letters, tell me which one is which. I don't have to think anymore about it. But it makes sense. If this is being oxidized and this is being reduced, this has to be the reducing agent that's impacting this compound. If this is being oxidized, oxygen has to be the agent that's forcing that to happen. Okay? That's the understanding behind the trick. All right. Let's do the practice problems together. And gives us calcium chloride and water and carbon dioxide. Okay. Oxidation numbers. Oxygen is going to have what oxidation number? Sorry, you can't see. -2. Calcium is going to have what oxidation number based on rule number 1? Group 2. So it'll have a what oxidation number? That means that carbon then must have what? We've got 2 plus X plus what? It is plus 4, but good job. -6 equals 0. X is equal to plus 4. You guys are quick with your math. Okay, hydrogen has what? +1. Chlorine has -1. Calcium has?
No, calcium with chloride would be
Okay. Chloride on this side here would be a this is 2. Yeah, it'd be -2. Oops. You're right. You're right. Hydrogen would be a, oxygen would be a, what'd you say, Declan? -2. Oxygen on carbonate or carbon dioxide would be, and carbon would be +4. Hey, you guys are smart. You don't even need to do all the little things on the side. But if you had to figure it out, you would have x plus 2 times negative 2 is equal to 0. X would be equal to positive 4. Okay, so calcium goes from 2 plus to 2 plus. Last, no change. Carbon, 4 plus to 4 plus. Oxygen, negative 2, negative 2, negative 2. Hydrogen, positive 1, positive 1. Chlorine, negative 1, negative 1. There is no change. Where there's negative 2 and negative 2. No, it's individually. That's a good question. So therefore, this is not a redox reaction. Okay, this is not a redox reaction. The next one. HNO2 going to nitric acid and nitrate and water. Okay, so HNO2 gives us, excuse me, gives us HNO3 plus NO2 plus H2O. So H has what? Plus what? Oxygen has what? Negative 2. Nitrogen would be plus 3, right? We have 1 plus x plus 2 times negative 2 is equal to 0. X would be equal to plus 3. Hydrogen is, oxygen is, nitrogen is plus 5. Okay, so we have 1 plus x plus 3 times negative 2 is equal to 0, so x is equal to positive 5. Okay. Oh, this is not NO2. This is my bad. This is not NO2. This is just NO. This is nitrous oxide. Sorry. Yeah, sorry. That's my fault. I read my notes wrong. Okay. Oxygen is, nitrogen would then be, say it again, Declan. Positive 2. Hydrogen would be, and oxygen would be negative 2. Okay. Are you good? You're good, Declan? Okay. All right. Hydrogen, 1, 1, 1. Nitrogen, 3 to 5. That's a change. And, down to 2. I'm just going to use the on the same side. Okay. Oxygen, negative 2, negative 2, negative 2, negative 2. That's it. So, what can we say about this kind of reaction? The reactant is both the oxidizer and the reducer. It's a disproportionate reaction. Yep. Disproportionate. Okay. And so when we look at the purple line and we go from a plus 3 to a plus 5, what's happening? It's oxidized. So is it gaining or losing electrons? And when it goes from plus 3 to plus 2, it's being reduced, which makes it gaining or losing electrons. Okay? We can. Did it ask us to? It says, determine whether each of the following reactions is redox. If so, identify the oxidizing. Yeah, we will do that. Just let me write this out. Okay, so it says that we have to identify if it's the oxidizer or the reducing. Well, this one is both. It's both the oxidizing agent and the reducing agent. When we go up here, there's no change. There is no oxidizer. There is no reducer. Let's look at not the questions in page 461, but let's look as a group at practice problems.